A motorcycle is a two- or three-wheeled motor vehicle. Motorcycle design varies greatly to suit a range of different purposes: long-distance travel, commuting, cruising, sport including racing, and off-road riding. Motorcycling is riding a motorcycle and related social activity such as joining a motorcycle club and attending motorcycle rallies. In 1894, Hildebrand and Amp Wolfmüller became the first series production motorcycle, and the first to be called a motorcycle. In 2014, the three top motorcycle producers globally by volume were Honda, Yamaha, and Hero MotoCorp. Motorcycles are usually a luxury good in the developed world, where they are used mostly for recreation, as a lifestyle accessory or a symbol of personal identity. In developing countries, motorcycles are overwhelmingly utilitarian due to lower prices and greater fuel economy. Of all the motorcycles in the world, 58% are in the Asia-Pacific and Southern and Eastern Asia regions, excluding car-centric Japan. According to the United States Department of Transportation, the number of fatalities per vehicle mile traveled was 37 times higher for motorcycles than for cars. Types. The term motorcycle has different legal definitions depending on jurisdiction. There are three major types of motorcycle: street, off-road, and dual-purpose. Within these types, there are many subtypes of motorcycles for different purposes. There is often a racing counterpart to each type, such as road racing and street bikes, or motocross and dirt bikes. Street bikes include cruisers, sport bikes, scooters and mopeds, and many other types. Off-road motorcycles include many types designed for dirt-oriented racing classes such as motocross and are not street legal in most areas. Dual-purpose machines like the Dual Sport style are made to go off-road but include features to make them legal and comfortable on the street as well. Each configuration offers either specialized advantage or broad capability, and each design creates a different riding posture. History, experimentation and invention. The first internal combustion, petroleum-fueled motorcycle was the Daimler Riding. It was designed and built by the German inventors Gottlieb Daimler and Wilhelm Maybach in Bad Cannstatt, Germany in 1885. This vehicle was unlike either the safety bicycles of the bone shaker bicycles of the era in that it had 0 degrees of steering, axis angle and no fork offset, and thus did not use the principles of bicycle and motorcycle dynamics developed nearly 70 years earlier. Instead, it relied on two outrigger wheels to remain upright while turning. The inventors called their invention the Riding. It was designed as an expedient test bed for the new engine, rather than a true prototype vehicle. The first commercial design for a self-propelled cycle was a three-wheel design called the Butler petrol cycle, conceived of Edward Butler in England in 1884. He exhibited his plans for the vehicle at the Stanley Cycle Show in London in 1884. The vehicle was built by the Merryweather Fire Engine Company in Greenwich. In 1888, the Butler petrol cycle was a three-wheeled vehicle, with the rear wheel directly driven by a 5/8 of a horsepower 600 cc flat twin four-stroke engine equipped with rotary valves and a float-fed carburetor and Ackermann steering, all of which were state-of-the-art at the time. Starting was by compressed air. The engine was liquid-cooled, with a radiator over the rear driving wheel. Speed was controlled by means of a throttle valve lever. No braking system was fitted. The vehicle was stopped by raising and lowering the rear driving wheel using a foot-operated lever. The weight of the machine was then borne by two small caster wheels. The driver was seated between the front wheels. It wasn't, however, a success, as Butler failed to find sufficient financial backing. Many authorities have excluded steam-powered electric motorcycles or diesel-powered two-wheelers from the definition of a motorcycle, and credit the Daimler Reitwagen as the world's first motorcycle. Given the rapid rise in use of electric motorcycles worldwide, defining only internal combustion-powered two-wheelers as motorcycles is increasingly problematic. If a two-wheeled vehicle with steam propulsion is considered a motorcycle, then the first motorcycles built seem to be the French Machot-Perrot steam velocipede, which patent application was filed in December 1868. Constructed around the same time as the American Roper steam velocipede, built by Sylvester H. Roper, Roxbury, Massachusetts, who demonstrated his machine at fairs and circuses in the eastern U.S. In 1867, Roper built about 10 steam cars and cycles from the 1860s until his death in 1896. Summary of early inventions. First motorcycle companies. In 1894, Hildebrand and Amp. Wolfmüller became the first series production motorcycle, and the first to be called a motorcycle. Excelsior Motor Company, originally a bicycle manufacturing company based in Coventry, England, began production of the first motorcycle model in 1896. The first production motorcycle in the U.S. was the Orientaster, built by Charles Metz in 1898 at his factory in Waltham, Massachusetts. In the early period of motorcycle history, many producers of bicycles adapted the designs to accommodate the new internal combustion engine. As the engines became more powerful and designs outgrew the bicycle origins, the number of motorcycle producers increased. Many of the 19th century inventors who worked on early motorcycles often moved on to other inventions. Daimler and Roper, for example, both went on to develop automobiles. At the turn of the century, the first major mass-production firms were set up. In 1898, Triumph Motorcycles in England began producing motorbikes, and by 1903 it was producing over 500 bikes. Other British firms were Royal Enfield, Norton and Birmingham Small Arms Company, who began motorbike production in 1899, 1902 and 1910, respectively. Indian began production in 1901 and Harley-Davidson was established 2 years later. By the outbreak of the First World War, the largest motorcycle manufacturer in the world was Indian, producing over 20,000 bikes per year. First World War. During the First World War, motorbike production was greatly ramped up for the war effort to supply effective communications with frontline troops. Messengers on horses were replaced with dispatch riders on motorcycles carrying messages, performing reconnaissance and acting as a military police. American company Harley-Davidson was devoting over 50% of its factory output toward military contract by the end of the war. The British company Triumph Motorcycles sold more than 30,000 of its Triumph Type H model to Allied forces during the war. With the rear wheel driven by a belt, the Model H was fitted with a 499cc air-cooled 4-stroke single-cylinder engine. It was also the first Triumph without pedals. The Model H in particular is regarded by many as having been the first modern motorcycle. Introduced in 1915, it had a 550cc side-valve 4-stroke engine with a 3-speed gearbox and belt transmission. It was so popular with its users that it was nicknamed the Trusty Triumph. Post-war, by 1920, Harley-Davidson was the largest manufacturer, with the motorcycles being sold by dealers in 67 countries. By the late 1920s or early 1930s, DKW in Germany took over as the largest manufacturer. In the 1950s, streamlining began to play an increasing part in the development of racing motorcycles, and the dustbin fairing held out the possibility of radical changes to motorcycle design. NSU and Moto Guzzi were in the vanguard of this development, both producing very radical designs well ahead of the time. NSU produced the most advanced design, but after the deaths of 4 NSU riders in the 1954 to 1956 seasons, they abandoned further development and quit Grand Prix motorcycle racing. Moto Guzzi produced competitive race machines, and by 1957 nearly all the Grand Prix races were being won by streamlined machines. The following year, 1958, full enclosure fairings were banned from racing by the FIM in the light of the safety concerns. For the 1960s through the 1990s, small two-stroke motorcycles were popular worldwide, partly as a result of East German Walter Carden's engine work in the 1950s. Today, in the 21st century, the motorcycle industry is mainly dominated by the Chinese motorcycle industry and by Japanese motorcycle companies. In addition to the large-capacity motorcycles, there is a large market in smaller-capacity motorcycles, mostly concentrated in Asian and African countries and produced in China and India. A Japanese example is the 1958 Honda Super Cub, which went on to become the biggest-selling vehicle of all time, with its 60 millionth unit produced in April 2008. Today, this area is dominated by mostly Indian companies, with Hero MotoCorp emerging as the world's largest manufacturer of two-wheelers. Its Splendor model has sold more than 8.5 million to date. Other major producers are Bajaj and TVS Motors. Technical aspects. Construction. Motorcycle construction is the engineering, manufacturing, and assembly of components and systems for a motorcycle, which results in the performance, cost, and aesthetics desired by the designer. With some exceptions, construction of modern mass-produced motorcycles has standardized on a steel or aluminum frame, telescopic forks holding the front wheel, and disc brakes. Some other body parts, designed for either aesthetic or performance reasons, may be added. A petrol-powered engine, typically consisting of between 1 and 4 cylinders coupled to a manual 5 or 6-speed sequential transmission, drives the swing arm-mounted rear wheel by a chain drive shaft or belt. Fuel economy. Motorcycle fuel economy varies greatly with engine displacement and riding style, ranging from a low of 29 mpg US reported by a Honda VTR 100F rider, to 107 mpg US reported for the Verucci Nitro 50cc scooter. A specially designed Matsuzawa Honda XL 125 achieved 470 mpg US on real highways in real conditions. Due to low engine displacements and high power-to-mass ratios, motorcycles offer good fuel economy. Under conditions of fuel scarcity like 1950s Britain and modern developing nations, motorcycles claim large shares of the vehicle market. Electric motorcycles' very high fuel economy equivalents are often derived by electric motorcycles. Electric motorcycles are nearly silent, zero-emission electric motor-driven vehicles. Operating range and top speed are limited by battery technology. Fuel cells and petroleum-electric hybrids are also under development to extend the range and improve performance of the electric drive system. Reliability. reliability. A 2013 survey of 4,424 readers of the U.S. Consumer Reports magazine collected reliability data on 4,680 motorcycles purchased new from 2009 to 2012. The most common problem areas were accessories, brakes, electrical and fuel systems, and the types of motorcycles with the greatest problems were touring, off-road, dual sport, sport touring, and cruises. There were not enough sport bikes in the survey for a statistically significant conclusion, though the data hinted at reliability as good as cruises. These results may be partially explained by accessories including such equipment as fairings, luggage, and auxiliary lighting, which are frequently added to touring, adventure touring, dual sport and sport touring bikes. Trouble with fuel systems is often the result of improper winter storage, and brake problems may also be due to poor maintenance. Of the 5 brands with enough data to draw conclusions, Honda, Kawasaki and Yamaha were statistically tied, with 11 to 14% of those bikes in the survey experiencing major repairs. Harley-Davidson's had a rate of 24%, while BMW's did worst, with 30% of those needing major repairs. There were not enough Triumph and Suzuki motorcycles surveyed for a statistically sound conclusion, though it appeared Suzuki's were as reliable as the other 3 Japanese brands, while Triumph's were comparable to Harley-Davidson and BMW. 3/4 of the repairs in the survey cost less than $200, and 2/3 of the motorcycles were repaired in less than 2 days. In spite of the relatively worse reliability in this survey, Harley-Davidson and BMW owners showed the greatest owner satisfaction, and 3/4 of them said they would buy the same bike again, followed by 72% of Honda owners and 60 to 63% of Kawasaki and Yamaha owners. Dynamics. Different types of motorcycles have different dynamics, and these play a role in how a motorcycle performs in given conditions. For example, one with a longer wheelbase provides the feeling of more stability by responding less to disturbances. Motorcycle tires have a large influence over handling. Motorcycles must be leaned in order to make turns. This lean is induced by the method known as countersteering, in which the rider momentarily steers the handlebars in the direction opposite of the desired turn. This practice is counterintuitive and therefore often confusing to novices, and even many experienced motorcyclists. With such short wheelbase, motorcycles can generate enough torque at the rear wheel, and enough stopping force at the front wheel, to lift the opposite wheel off the road. These actions, if performed on purpose, are known as wheelies and stoppies respectively. Accessories. Various features and accessories may be attached to a motorcycle either as OEM or aftermarket. Such accessories are selected by the owner to enhance the motorcycle's appearance, safety, performance, or comfort, and may include anything from mobile electronics to sidecars and trailers. Safety. Motorcycles have a higher rate of fatal accidents than automobiles or trucks than buses. United States Department of Transportation data for 2005 from the Fatality Analysis Reporting System show that for passenger cars, 18.62 fatal crashes occur per 100,000 registered vehicles. For motorcycles, this figure is higher at 75.19 per 100,000 registered vehicles, 4 times higher than for cars. The same data shows that 1.56 fatalities occur per 100 million vehicle miles traveled for passenger cars, whereas for motorcycles the figure is 43.47, which is 28 times higher than for cars. Furthermore, for motorcycles the accident rates have increased significantly since the end of the 1990s, while the rates have dropped for passenger cars. The two major causes of motorcycle accidents in the United States are motorists pulling out or turning in front of motorcyclists and violating the rights of way, and motorcyclists running wide through turns. The former is sometimes called ASMIDSY, an acronym formed from the motorist's common response of "Sorry mate, I didn't see you." The latter is more commonly caused by operating a motorcycle while intoxicated. Motorcyclists can anticipate and avoid some of these crashes with proper training, increasing the visibility to other traffic, keeping the speed limits, and not consuming alcohol or other drugs before riding. The United Kingdom has several organizations dedicated to improving motorcycle safety by providing advanced rider training beyond what is necessary to pass the basic motorcycle license test. These include the Institute of Advanced Motorists and the Royal Society for the Prevention of Accidents. Along with increased personal safety, riders with these advanced qualifications may benefit from reduced insurance costs in South Africa. The Think Bike campaign is dedicated to increasing both motorcycle safety and the awareness of motorcycles on the country's roads. The campaign, while strongest in the Gauteng province, has representation in Western Cape, KwaZulu-Natal and the Free State. It has dozens of trained marshals available for various events such as cycle races and is deeply involved in numerous other projects such as the annual motorcycle toy run. Motorcycle safety education is offered throughout the United States by organizations ranging from state agencies to non-profit organizations to corporations. Most states use the courses designed by the Motorcycle Safety Foundation, while Oregon and Idaho developed their own. All of the training programs include a basic rider course, an intermediate rider course and an advanced rider course. In Ireland, since 2010, in the UK and some Australian jurisdictions, such as Victoria, New South Wales, the Australian Capital Territory, Tasmania and the Northern Territory, it is compulsory to complete a basic rider training course before being issued a learner's license, after which they can ride on public roads. In Canada, motorcycle rider training is compulsory in Quebec and Manitoba only, but all provinces and territories have graduated license programs which place restrictions on new drivers until they have gained experience. Eligibility for a full motorcycle license or endorsement for completing a motorcycle safety course varies by province. The Canada Safety Council, a non-profit safety organization, offers the Gearing Up program across Canada and is endorsed by the Motorcycle and Moped Industry Council. Training course graduates may qualify for reduced insurance premiums. Motorcycle rider postures. The motorcyclist's riding position depends on rider body geometry combined with the geometry of the motorcycle itself. These factors create a set of three basic postures. Sport. The rider leans forward into the wind and the weight of the upper torso supported by the rider's core at low speed and air pressure at high speed. The foot pegs are below the rider to the rear. The reduced frontal area cuts wind resistance and allows higher speeds. At low speed, this position throws the weight of the rider onto the arms, which can tie at the rider's wrists. Standard. The rider sits upright and leans forward slightly. The feet are below the rider. These are motorcycles that are not specialized to one task, so they do not excel in any particular area. The standard posture is used with touring and commuting as well as dirt and dual sport bikes, and may offer advantages for beginners. Cruiser. The rider sits at a lower seat height with the upper torso upright or leaning slightly rearward. Legs are extended forwards, sometimes out of reach of the regular controls on cruiser pegs. The low seat height can be a consideration for newer short riders. Handlebars tend to be high and wide. The emphasis is on comfort, while compromising cornering ability because of low ground clearance and the greater likelihood of scraping foot pegs, floorboards, or other parts if turns are taken at the speeds other motorcycles can more readily accomplish. Factors of a motorcycle's ergonomic geometry that determine the seating posture include the height, angle and location of foot pegs, seat and handlebars. Factors in a rider's physical geometry that contribute to seating posture include torso, arm, thigh and leg length, and overall rider height. Legal definitions and restrictions. A motorcycle is broadly defined by law in most countries for the purposes of registration, taxation and rider licensing as a Part 2-wheel motor vehicle. Most countries distinguish between mopeds of 49 cc and the more powerful, larger vehicles. Many jurisdictions include some forms of three-wheeled cars as motorcycles. Environmental impact. Motorcycles and scooters' low fuel consumption has attracted interest in the United States from environmentalists and those whom increased fuel prices affect. Piaggio Group Americas supported this interest with the launch of a Vesponomics website and platform, claiming lower per mile carbon emissions of 0.4 pounds/mile less than the average car, of 65% reduction, and better fuel economy. However, a motorcycle's exhaust emissions may contain 10 to 20 times more oxides of nitrogen, carbon monoxide, and unburned hydrocarbons than exhaust from a similar year passenger car or SUV. This is because many motorcycles lack a catalytic converter, and the emissions standard is much more permissive for motorcycles than for other vehicles. While catalytic converters have been installed in most gasoline-powered cars and trucks since 1975 in the United States, they can present fitment and heat difficulties in motorcycle applications. United States Environmental Protection Agency 2007 certification result reports for all vehicles versus on-highway motorcycles. The average certified emissions level for 12,327 vehicles tested was 0.734. The average NOx plus co-end of useful life emissions for 3,863 motorcycles tested was 0.8531. 54% of the tested 2007 model motorcycles were equipped with a catalytic converter. United States emissions limits. The following table shows maximum acceptable legal emissions of the combination of hydrocarbons, oxides of nitrogen, and carbon monoxide for new motorcycles sold in the United States with 280 cc or greater piston displacement. The maximum acceptable legal emissions of hydrocarbon and carbon monoxide for new Class 1 and 2 motorcycles sold in the United States are as follows. European emission standards for motorcycles are similar to those for cars. New motorcycles must meet Euro 3 standards, while cars must meet Euro V standards. Motorcycle emission controls are being updated, and it has been proposed to update to Euro IV in 2012 and Euro V in 2015.